Hey guys, it's Miss Manili, and I'm sorry I can't be in class today. I'm still going to go ahead and present the lesson, so don't worry, you won't miss a thing. The first thing I want to do is go over the warm-up, and I think what you'll notice is that in the warm-up we're talking about circles. So we're kind of transitioning from right triangles to circles, and so we're going to be talking about the geometry and trigonometry of circles, and we'll actually be going back and forth relating the angles in a triangle to the angles in a circle, and we'll get to that in a couple of days. First off, what is the formula for the circumference of a circle? So if we have a circle of radius r, the circumference, remember, measures the distance around the circle. Okay, and the circumference, if you remember, is just going to be 2 pi r. And so how are the diameter and the radius of a circle related? So a diameter, remember, goes all the way across the circle through the middle, and the radius just is the ray that goes from the center of the circle to the outside. So the diameter is going to equal twice the radius. And so in number 3 it says, what is the circumference of a circle that has a radius of 5 inches? So I'm going to use my circumference formula, 2 pi times r, and r in this case is 5, so that is just going to be 10 pi. And I'm just going to go ahead and let you know that for these problems, in fact, for most of what we're going to be doing in this unit, you're going to leave pi in your answer. So that's how we actually express the exact answer. Because if I were to go into my calculator and type in 10 times pi, and you notice you do have a calculator, I'm sorry, you do have a pi symbol on your calculator. If you hit second and that little caret button, you can get the value of pi. And then you get this number here. That is considered an irrational number, so even when we round, it's not going to be exact. It does kind of let me know where the value is on the number line. It's a little bit more than 31, in this case, inches. But to be exact, we're going to leave pi in our answer. So 10 pi is going to be the correct answer, even though it's kind of hard to tell what 10 pi means. In number 4, it says, what's the circumference of a circle that has a diameter of 7? I need to be a little bit more careful here because the formula that I use for circumference involves the radius. So I have to think about what is the radius if the diameter is 7. So I know that 7 then is going to be equal to 2 times r. And if I divide both sides by 2, that means that my radius must be 3.5. And so if I want to find the circumference of the circle, it's going to be 2 pi times 3.5. Actually, you can put that in parentheses. And 2 times 3.5 is just going to be 7. So this is ultimately going to be 7 pi. Another way to think of it is, since I have the 2 and the r in my formula for circumference, another way to think of the formula would just be to say pi times the diameter. And those are the same thing as well. In number 5, it says, what is half the circumference of a circle with a radius of 6 inches? So it says to sketch the graph. So let's just go ahead and use the sketch that we have. If this is 6 inches, it's asking about what is half the circumference. Well, the whole circumference is just going to be 2 pi times 6. And if I want half of that, I'm just going to divide the whole thing by 2. And so if I'm just dealing with the numbers, again, I'm going to leave pi in my answer. That's going to be 12 pi over 2, which is going to reduce to 6 pi. Now let's think about the area of a circle. Remember, the area now refers to the values of the space inside the circle. That's now two-dimensional. And so anytime you're dealing with area, you should see a square. If I'm dealing with volume, you should see a cube. So the formula for area is pi r squared. And so it asks, what is the area of a circle that has a radius of 3 centimeters? So the area would be pi times 3, the quantity squared. And ultimately, that's going to be 9 pi centimeters. And then in number 8, it says, what is the area of a quarter of a circle with a radius of 4 inches? So again, I'm going to draw a picture. Here's my circle. Let's say my radius is 4. And I want to know an area of the quarter. So let's say I go like this. I want to know that area right there. So it's basically going to be 1/4 of the area, pi r squared. And so that's going to basically, if I multiply that out, it'll be 16 pi over 4, which is simply 4 pi. And that would be in inches squared. Okay, so we're going to spend a little bit of time talking about circles. and angles relating to circles. So let's talk a little bit more about angles. We're going to step away from triangles for a little while, and let's just talk about just a generic angle as it's formed by two rays. So we know an angle is a measure of rotation, and we're going to start by looking at angles measured in degrees. But one of the things that you may not know is that angles can have negative values as well, because an angle can be measured, or it measures the direction and the angle size. Most of the angles that we've looked at so far have all been positive. So the angle measure is basically the amount of rotation between two rays that form the angle. The rotation is measured from the initial side to what we call the terminal side. That would be this side. And that's the two rays that form the angle. When the angle has its initial side on the x-axis, so if I were to kind of think of this as, actually maybe let's do this with black ink. So if I looked at this as though it's on the coordinate plane, since my angle is on the x-axis, I would say this is in standard position. The alternative would be if I were looking at an angle such as this, and looking at that angle, or like this. That would be a different type of angle. Neither one of these angles would be in standard position, and it wouldn't matter what you called the initial side or the terminal side. But we're going to focus on all angles that are in standard position, so the initial side is going to be on the x-axis. And again, that would be my terminal side. One complete rotation is going to be a measure of 360 degrees. And if you think about it, if you wind that initial side around all the way, it's going to form a circle. And we know that the measure of that angle is going to be 360 degrees. But again, an angle can measure as a positive value or a negative value depending on the direction of the rotation. So an angle will measure positive if we go in a counterclockwise rotation. And if you think about the quadrants, if you're thinking of this on a coordinate plane where this is my x-axis and this is my y-axis, my coordinates are my quadrants are 1, 2, this is my third quadrant, and my fourth quadrant. And so if I go in order, I'm going counterclockwise, and that's going to give me a positive angle. If you take a look at the other example, this time, even though my initial side is still in the standard position, if I swing that terminal side this way, it gives me a negative angle. Another thing you can realize is that all angles actually have both sides. So while this angle measures negative 245 degrees, the angle on the inside is going to be the other part of that. So if I take 360 minus the 245, the angle on the inside is going to measure a positive 115 degrees. Okay. So in the first example, it says, what are two angles that both have the same terminal side in the circle below? So if I assume that this is a right angle, and this is my initial side, if I go counterclockwise, the angle that is formed here is going to be a positive 90 degrees. But if I go the other way, clockwise, that angle is going to measure the other 360. So if I do 360 minus 90 degrees, I'm going to get 270 degrees. But because I've gone in the clockwise motion, this is going to be a negative 270 degrees. And then number 2, so notice we could have negative angles, and then number 2 says that we actually have an angle that measures 390 degrees. So an angle that measures 390 degrees, if this is my initial side, where would the terminal side be? So this is a positive angle, so I want to go counterclockwise. So if I go all the way around, I know that's 360 degrees. So to get to 390, I'd need to go another 30 degrees. And basically what that means is An angle that measures 390 degrees is equivalent to 30 degrees. And an angle that measures negative 270 degrees is equivalent to a 90-degree angle. And so when we write our angles, we want to make sure that we write them from standard position. So we want to make sure that all of our angle values are between 0 and 360. So if they end up being negative, what we'll do is we'll add 360. So if you take the negative 270, we need to fix it so it's in standard position. So we add 360 to that, and that'll give us the 90 degrees. And if our angle is too big, so if it's 390, we'll need to subtract the 360 to get the angle back into standard position. So again, standard position basically means that our angle measures between 0 and 360 degrees. If it's negative or if it's more than 360, we need to correct it so that it's in standard position. Okay, so we also can measure angles using something called radians. And so a radian, instead of measuring this part of the angle, it's measuring this part of the angle. It's a little bit, so we're just looking at the same angle but from a different perspective. So a radian is the angle made at the center of the circle by an arc whose length is equal to the radius of the circle, which I think is kind of confusing. Radians also measure the distance traveled on the circle. So I want you to imagine, since I'm not here to actually demonstrate this with students, I want you to imagine two students. I'm going to have student A standing right here. So this is student A. And then I'm going to have student B standing right here. Okay? Student A is going to stand still and is going to look at student B. And then student B is going to start walking. Now, if student A moves nothing but his head is going to have to rotate to follow student B to the second position. So this part of the angle is what we would usually measure in degrees. This part of the angle is what we would measure in radians. If you think about it, it's measuring the same quantity, but it's just looking at it from a different perspective. So the central angle, that would be this thing here. We usually use a Greek symbol theta to describe it. Sometimes that's called the interior angle in a circle. And the symbol that we use is this Greek symbol. It looks like an O with a line straight through it, and it's called theta. So the circumference of a circle, we could say, is 2 pi r, or we can simply say it's 2 pi radians, because the radians are going to correspond to the circumference of a circle. And very often we want to translate between the radians and degrees. So if you think about it, I know, actually let me skip to the next slide. So I know, for example, if I'm dealing with a whole circle here, and I'm dealing with the angle within, so if this is my initial side, if I'm thinking about this angle, that's 360 degrees. If I think about one full rotation around this part, that's going to correspond to 2 pi radians. So it turns out that 360 degrees and 2 pi radians are equivalent quantities. So if I want to be able to translate back and forth, so for example, if I wanted to solve for radians, I would simply divide both sides by 2 pi. My 2 pi's are going to cancel, and I'd have 1 radian is equal to 360 degrees divided by 2 pi. And if I reduce that, it's 360 divided by 2 is just going to be 180 over pi. I could do the same thing if I wanted to solve the other way. So we have 2 pi radians is equal to 360 degrees. And if I wanted to solve for degrees, I would simply divide both sides by 360. My 360s are going to cancel, so I'm going to have 1 degree over here. And then if I think 2 pi divided by 360, one of the things you guys are going to be getting in the habit of doing is simplifying fractions. The pi is going to stay in my answer. So if I just think of 2 divided by 360, and then I go to math, and then I choose my fraction option, it'll reduce my fraction into lowest terms. So that's just going to be 1 over 180. So 1 degree is equivalent to pi over 180. So if I want to convert, so let's say Let's say I have an angle that measures, let's just go ahead and do 90 degrees. If I want to take 90 degrees, actually let's start with 180. Let's do half of a circle, because I think this will make a little bit more sense. So if I have 180 degrees, oops, 180 degrees. 180 degrees is a straight line, right? 180 degrees. If my whole circle is 2 pi, then 180 degrees corresponds to half of a circle, which means that 180 degrees is going to equal 1 pi. So if I think about translating 180 degrees into radians, since my 180 degrees does not have a pi associated with it, I'm going to want to convert by multiplying by pi over 180. When I do that, my 180s are going to cancel, and I'll be left with pi. So that kind of shows you that 180 degrees is equivalent to pi. So to convert degrees to radians, so if I have degrees, that means I don't have a pi, I'm going to multiply by the fraction that has pi in the numerator. Once we start doing some examples, you'll see what I mean. If I'm already in radians and I want to switch to degrees, that means I already have a pi in my value and I want to get rid of it. So I will multiply by the quantity that has pi in the denominator. So let's just take a look at some examples so you see what I mean. If I want to convert 255 degrees into radians, I'm either going to be multiplying by pi over 180 or 180 over pi. Well, if I want to convert it into radians, I need to have the pi on top. So that's the quantity I'm going to multiply by, times pi over 180. And just think about your rules for multiplication. 255 is a whole number, so I can put it over 1. So this actually is the same thing as 255 pi over 180. And if I want to simplify that fraction, and again, I'm just going to leave the pi alone. I'm not going to try to multiply it out or anything. If I just want to simplify the 255 over 180, I'm going to do that on my calculator. 255 divided by 180, and then just use that math change to fraction command, and it'll give you the fraction in lowest terms. So we get 17 over 12. So this is the same thing as 17 pi over 12. And you're going to leave your answer just like that. If I take a look at number 4, I want to change 15 degrees to radians. And again, I don't have a pi, so I'm going to multiply by the quantity that has pi on top. So this is the same thing as 15 pi over 180. So I need to reduce that fraction. So I'm going to do 15 divided by 180. And then I'm going to change it to a fraction in lowest terms, and that's 1/12. So I'm going to write my final answer as pi over 12. Now, when I look at number 5, I actually run into a problem because it's negative. And remember, I said that in standard form, all of your angles should be between 0 and 360. If I'm dealing with radians, they'd have to be between 0 and 2 pi. So I have a problem here because my angle is a negative angle. So what I need to do is correct it. So anytime your angle starts off as negative, you're going to add 360. So negative 140 plus 360 means that a negative 140 angle is equivalent to a 220 degree angle. And so negative 140 is equivalent to 220. So now I can take my 220 degree angle and multiply that by pi over 180. In fact, I'm just going to turn it into one fraction. And then I can simplify. 220 divided by 180. Change back to a fraction. And that gives me 11/9 or 11 pi over 9. So what do you think I would do in number 6? 390 is definitely bigger than 360. And so if my angle is too big, I need to get it in standard position first and then change it into radians. So in this case, if it's too big, I'm going to subtract 360. I'm going to kind of unwind that angle. And that's going to give me a positive 30 degrees. So a 390 degree angle is equivalent to a 30 degree angle. And again, if I'm trying to change that into radians, I'm going to multiply by pi over 180. And so I'm going to simplify 30 divided by 180, change it to a fraction, and I get 1/6. So this is equivalent to pi over 6. Okay? I'd like you to pause the video at this point, and I'd like you to try number 7 and number 9. Now with number 7, I think you can notice that it's a little too big. And if you subtract 360, it might still be a little too big. So subtract 360 again, and then multiply. But please go ahead and press pause. Okay, let's check your work. And I was actually wrong. When you subtract 360 from 712, you get 352, and that is an angle in standard position. So when you multiply by pi over 180 and simplify it, you should get 88 pi over 45. With number 9, since that angle starts off being negative, you'll have to add 360, which means it's equivalent to a 35-degree angle, and that translates into 7 pi over 36. So let's take a look at the second part of this. If I take a look at the second part, notice now I'm starting with radians. I've got a pi that I'm starting with, and in order to change it to degrees, I got to get rid of it. So if I'm starting off with pi, the way I get rid of it is to divide by pi. So when I have radians, I want to multiply by the quantity that has 180 over pi. So if I'm starting off with 2 pi over 3, this is the one where I'm going to be multiplying by 180 over pi. And when I do that, my pi's now will cancel. And I've got 2/3 times 180. I can actually just do that right on my calculator. 2/3 times 180. And I get 120. And now when I write 120, I'm going to use the degree symbol. In number 11, we've got 5 pi over 6. And again, I'm going to multiply this times 180 over pi. My pi's are going to cancel. So I can do 5/6 times 180. And we get 150. Okay. If we take a look at 9 pi over 4, again, I'm going to multiply by 180 over pi, and my pi's are going to cancel. So we'll do 9/4 times 180. And I get 405. Now, am I allowed to leave my answer that way? If it's over 360, I have to simplify it. So I'm going to actually subtract the 360. And when I do that, I'm going to get 45 degrees. So a 405-degree angle is equivalent to a 45-degree angle. In number 13, notice that we're starting off with something that's negative. Don't worry about the negative yet. We're going to change it to degrees and then add 360. So I'm going to keep the negative in there. So I've got negative 2 pi over 3, and I'm going to multiply by 180 over pi so that I can cancel those pi's. And then when I multiply, I'm going to do negative 2/3, I'm not changing anything yet, times 180. And I get negative 120 as my answer. But I can't leave my answer that way because I can't leave it as a negative number. So to correct it, I add 360. And when I do that, I get 240 degrees. And I can leave my answer that way. So again, I'd like you to go ahead and pause the video. And I'd like you to do problems 14 and 15. Okay, so when you take negative 5 pi times 180 over pi, and you multiply, those pi's cancel, and you end up with a negative 900. So we know we need to add 360. But when I do that, I still have a negative 540. So I need to add 360 again, which is going to leave me with a negative 180. So I keep adding 360. Because basically, all this is negative 5 pi. If this is my standard position, this is 1 pi. If I go all the way around, that's 2 pi. If I go here, that's 3 pi. If I go around, that's 4 pi. So 5 pi ends right here. So it forms a straight line. So it makes sense that 5 pi is equivalent to 180. And I actually might have gone in the wrong direction because since our angle was negative, I should have actually been going like this. Been going backwards. And the same with number 15. If it's negative 15 pi over 2, I'm going in the clockwise position or clockwise direction, and I'm going around and around and around several times. And so in order to get back into standard position, I'm going to unwind it, and it looks like I have to go around 4 times before it ends up being a positive 90. The last thing I want to show you in the lesson has to do with arc length. So if you have a circle, and let me use a red pen. if you have a circle and we've got an interior angle here that is measured in radians, I want to be clear that this only works, or this formula can only be used when our interior angle is measured in radians. If I want to calculate the distance traveled, it's obviously going to depend. If I have a small circle, the distance traveled is going to be much different than if I have a large circle. Even if the angle is the same, the distance traveled is going to be more if I have a larger circle. So I need to take into consideration the radius of the circle. And that distance that we're traveling is called an arc. And so arc length is equivalent to r times theta, as long as theta is measured in radians. Okay, so it's basically the same thing that we were doing before in terms of the length of the radian measure of a circle is assuming that the radius is equal to 1. That arc length is going to just depend on the width of the radius. So in these next two problems, in number 16, you're given the radius is 12, you're given the value of theta, that's our interior angle, is pi over 2. So if I want to find the arc length, and sometimes we use the symbol S to represent arc length. I don't know why. It's not labeled with something other than an S since there's no S in the word. But anyway, arc length is equivalent to the variable S, and it would multiply 12 times the radians, which would be pi over 2. And again, like this is just 12 over 1, and this will ultimately be 12 pi over 2, and I can simplify that fraction to be 6 pi. Now in this case, because I'm measuring the arc, I don't have to, this isn't measuring the radians of an angle, it's measuring the distance around a circle. So I don't have to subtract 360, I don't have to worry about the fact that it's more than 2 pi. In number 17, pay attention to the fact that you're given the diameter here, and my formula uses the radius. So if my diameter is 2, I've got to remember my radius is only 1 meter. And so if I want to find my arc length, again, we'll use the variable S. It's going to be 1 times theta, which in this case is 3 pi over 4. And again, that's just going to be 3 pi over 4. Now, it is measuring a distance, so we should also include the units. So in this case, it would be meters. In this case, it would be centimeters. So why don't you guys go ahead and pause the video and find the arc length in problems 18 and 19. Okay, so with these last two problems, in number 18, our radius is 16 centimeters, and our measure of our degree, our radians are 11 pi over 6. When you multiply, you're multiplying a whole number times a fraction. And on your calculator, again, you can do this math without putting in pi. It's just going to be 16 times the fraction, 11 over 6. And then again, you can just use that conversion to fractions, that command on your calculator, and that gives you 88 thirds. So that'll be 88 pi over 3, and then again, that's in centimeters. And then for number 19, the radius is 2, your interior angle is pi over 3, and when you multiply them together, you get 2 pi over 3 meters. And I forgot to put meters. Should be feet. All right. So hopefully that makes sense. You've got a classwork assignment that I'd like you to go ahead and work on. You may work with another person if you like, or you can work independently. Miss Brown will be here to help you, and she has the answers available if you need any extra help. Good luck, and I will be here on Tuesday if you need to see me during Build Out Block.